Hello friends, in today's question, two smooth blocks are placed on a smooth corner as shown in figure. Both blocks having mass m, we apply a force F on the small block A. Block A presses block B in the normal direction, due to which pressing force on the vertical wall will increase, and pressing force on the horizontal wall decreases as we increase F. And theta is given as 37 degree with the horizontal. As soon as the pressing force on the horizontal wall by the block B becomes 0, it will lose contact with the ground. If the value of F further increases, block B will accelerate in the upward direction and simultaneously block A will move towards the right. So we are going to calculate these three things. What is the minimum value of F to lift block B from the ground? B part. If both blocks are stationary, the force exerted by the ground on the block A is. And last is, if the acceleration of block A is rightwards, then the acceleration of B will be. So these are two blocks A and B, and they are at an incline with each other, connected with each other, or we can say touching each other. A force F is being applied on the block A, and the angle of, you can say, the width A is making with the horizontal is 37 degree. So in the first part, we are going to find out what will be the minimum value of force F in order to lift the block B from the ground. So let us draw the free body diagram for block A as well as block B, and then we can solve it. You can say for block A, this is our 37 degree. A force F is being applied on it, and let us suppose there is a normal N because of the contact A and B, and this normal can be divided into two parts. So this will be our N cos of theta, and this will be our N sin of theta. In the downward direction there will be mg, and there will be normal. Let us suppose that normal is NA. This is A block. So from here, in case of equilibrium, we can say the applied force F will be equal to N sin of theta, and from here we can find out that our N is equal to F upon sin of theta. Now let us draw the block B. Block B, and there will normal N, which can be divided into two parts. We have N sin of theta, this angle will be theta, and this will be N cos of theta, and also in the downward direction we are going to have mg. So it is asked then to lift the block B from the ground. So block B will be lifted from the ground when N cos theta is greater than mg. Okay. You can say block B will lift from the ground if N cos theta is greater than or equal to mg. we already know value of n. Okay, so we can say n is of f sine of theta. So we get f sine of theta multiplied by cos of theta is greater than equal to mg. And we are required to find out the minimum force. So we can say the minimum force F minimum will be equal to mg sine theta divided by cos theta. And we can say F minimum is equal to mg tangent of theta, and here theta is given as 37 degree. You can say mg tangent of 37, which is 3 by 4. So we get minimum force is equal to mg 3 by 4. So this is the minimum value of the force required to lift block B from the ground. This is the minimum value of force F required to lift block B from the ground. The second part, it said that if both blocks are stationary, the force exerted by the ground on the block A. So we are going to find the value of the normal. It's given that both blocks are stationary. You can say if block A is stationary, then it will be in equilibrium. Therefore, we can say downward force is our two forces, mg and n cos theta, and upward force is na. So from here we can write that na is equal to mg plus n cos of theta. And we already know value of n. You can say mg plus f upon sine theta cos theta. Therefore, we get that na is equal to mg plus f cot of theta, and which will be equal to cot theta 37, which will be equal to mgf cot of 37, which will be 4 by 3. So we can say na mg plus, you can say 4 by 3f. So this is the normal force exerted by, this is the force exerted by the ground on the block A. This is the force exerted by the ground on block A. And finally, we are supposed to find out if the acceleration of block A is rightwards, then the acceleration of block B will be. Okay. So we are going to find out acceleration. So let us draw the free body diagram of both the blocks once again. And block A, block B, and the acceleration of A is rightwards in this direction. and we can divide this acceleration into two parts. Okay. One will be along the inclined plane and another will be in this direction. Let me draw it again. Block A, block B, and we have acceleration of A in this direction. So it is going to have two components. One will be in this direction and another one will be in this direction. This angle is given as theta. So we have this angle also theta. This comes as A cos of theta, and this will be A sine of theta. And this is wall. So because of this wall, the block B will try to move in upward direction, and let us suppose its acceleration is given as B. Now once again, we can divide this acceleration also into two components. So we are going to have this as B cos of theta, and this will be our B sine of theta. This angle will be theta. So from here we say that as block A tries to move rightward, with acceleration A, and we can say block B will try to move upward with acceleration B. Okay. Now the important thing is that both the blocks should be always in contact with each other. Okay. This will be only possible if block A and block B always remain in contact. Remain in contact. So under this condition, we have two forces, that is A sine of theta and B cos of theta. They should be same. Okay. Therefore, A sine of theta should be equal to B cos of theta, and we are required to find out acceleration of block B. So we can say B will be equal to A sine theta divided by cos theta, and which comes as A tangent of theta, that is A tangent of 37. Therefore, B will be equal to 3 by 4 A, and this value is coming as positive. It means the direction which we have assumed initially, that it will be moving upward, is the correct option. Okay. So this is the acceleration of block B in upward direction. So this completes the question. Thank you.